Is this visible for everyone? Pratigya, Barinder, Channa, Jordan, and Sarah.
Yes, sir.
Yes, sir.
Okay. So, because we did Kepler's law, I will revise Kepler's law quickly. Don't worry, whatever we miss, because we need proper notes for the future. But now we are starting with the Newton's law of gravitation. I did this also, so I'll make it little bit quick, not little bit, too too quick. So first topic is Newton's law of gravitation. Chandana, what is this? Newton law of gravitation.
So every body attracts every other object with a force which is directly
Huh,
proportional to mass and
huh,
inversely proportional to distance.
correct. So remember here we talk only about attraction. Example, in case of Coulomb's law of electrostatic, there could be attraction or repulsion. Here only attraction. Got it? Second, the force of attraction, directly depend upon the mass, inversely depend upon the distance. More mass, more attraction. More distance, less attraction. That's why you will feel the difference in case of planet or satellite because mass is too much. Example, if we consider two human beings or two dead bodies, they do attract each other. But this force is so small that we don't consider. Okay. When you remove proportionality constant, it will be G M1 M2 by R square. Jordan, is this G value fixed or it will change depend upon the medium?
Medium as in like planet, no, sir.
No, 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 like you take in vacuum, air, any two body
No,
because
it
we
won't change. No, 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 won't change.
exactly. So if you take electrostatic force in case of Coulomb's law, so it electrostatic force will change if you change the medium because it depend upon the medium as well. Epsilon, not only epsilon naught, also depend upon the epsilon. But here it does not depend upon the medium. That's why G value will remain fixed whatever is the situation. Understood? G value will be fixed whatever is the situation. That's why this gravitation constant G value is fixed. It is 6.67 into 10 raised to power what? Pratigya, 10 raised to power minus 11 Newton meter square per kg square. Okay, unit is extremely important. Remember, you will miss unit. Is this G scalar quantity or vector quantity? Scalar.
Scalar, sir.
It does not depend upon any direction. Will it remain same in every medium? Yes. G does not depend upon the nature and size of body. It does not depend. And all of you have to write notes. So keep writing on the nature and size of body. Got it? Is this formula of F is applicable for any unsymmetrical body? Answer is no. Even in if you take electrostatic force, you will consider point mass. Only point mass is applicable. Only point mass is applicable because if body is unsymmetrical, then getting G value will be difficult. Right? Getting G value will be difficult. Does it obey Newton's law of motion? Answer is yes. If you take this, we are talking about the gravitation force G. G means gravitation force. So there are few points you need to understand in case of gravitation force. Example, gravitation force develop in the form of action and reaction both. That's why it obey Newton's third law of motion. It obey Newton's third law of motion. It means there is action and reaction and force occur in case of pair. If you compare with other force, this force is the weakest of all fundamental force. Weakest of all fundamental force. Okay. Um, Barinder, what are the fundamental force? Barinder, what are the fundamental force? Chandana, what are the fundamental force? Chandana,
Sir,
what are the fundamental force?
so like basic forces.
Yes. So you have four fundamental force. One is strong nuclear force, electromagnetic force, weak nuclear force, and gravitation force. These are the four. Out of these four fundamental force, a strong nuclear force is the strongest and gravitation force is the weakest. Got it? So you should know, like, this is usually teach in the it taught in a unit and measurement. You have four different type of force. Out of them, strong nuclear force is the strongest and the gravitation force is the weakest. Gravitation force between two bodies is independent of the presence or absence of the other body. Which simply mean is कि if you take two body A and B and they are exerting some force on each other, gravitation force. If you put third body C, there will be no impact between A and B. No doubt B will interact with C, A will interact with C, but between A and B, there will be no difference. Understood? So, we are talking about gravitational force. It is independent of third body absence or presence. If third body is absent or present, it does not matter. Force between two body will remain same. Got it? Force between two body will remain same. Why? Because it does not depend upon the third body independent. Got it? Next, if you talk about the fourth point, gravitation force always act along the lining joint. So this gravitation force is central force. What does it mean? It means if you have body 1 A, you have body B, the force will act between the line joining them. Right? Force act where line joining them. Next, gravity. Who will tell? Sarah, is gravitation force conservative force? Is gravitation force conservative force? Yes. How do we know? Because it does not depend upon the path. It does not depend on the path. Any doubt, Sarah?
No.
Huh. On path. Jordan, if you take any particle in the closed path under gravitational force, what will be the work done?
Sir, can you repeat the question again, sir?
If you see action of the gravitational force in a closed path, what will be the work done in closed path?
Zero, no.
Yes. Why? Because it is a conservative force.
Conservative.
If you take a round trip, then what will happen? Work done will be zero.
Equal to zero.
Hmm? के? ये तो जानते हैं। ये तो जानते हैं। बैठते थे आगे। Any doubt, guys?
No, sir, no doubt.
Just give me 1 minute, guys. ठीक है पहले बैठा ले ये आगे टूट जाए बैठो उठा ले मौसी कम से कम मेरी माँ का नया तो आवागा ना 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 यू ले जी मेरी माँ नया लेकर आवांगे उसका okay guys so this is done now we can solve question am I audible
Yes, sir.
so example if you have infinite number of mass each mass m is located example I will write question not like infinite number of mass each is m okay and they are placed at the position example x is equal to 1 or x is equal to 2 then and keep going on to the infinite then x is equal to 4 and same like this infinite find the magnitude of the gravitation force on the particle at origin 0 gravitation force you have to calculate where on particle at x is equal to 0 and how it is placed it's like this key first mass is placed at xm second mass x is equal to 1m third mass x is equal to 2m fourth mass x is equal to 4m and keep going on yes you got answer who have math now Chandana, you have to apply geometric progression here. You have to apply geometric progression here. And if you take it for the infinite number of time, the total value for infinite will be the initial value 1 minus r. Correct? So, what is the a in this situation? A is the initial or first term.
16 gm square by 15.
16 by
15 gm square.
gm square. Okay. And r is will be the common ratio.
16 by 15.
16 by 15. Okay. So, what will happen if you calculate gravitation force acting on M? Like, place at the center. We are talking about this only. So, how to calculate gravitation force in this case? You will calculate V know G M1 M2 by R square. Correct. And can we calculate G? Both mass are same. G M square divided by what is R value in first situation? 1 square. Second situation 2 square. Third situation 4 square. Then it will be 8 square. Then 16. It will keep becoming double every time. Correct. So if you make it double and take common value, G M square is the common value. 1 by 1 square is 1. 2 square 4. 4 square 16. And keep going on like that. Make sense? So this value, what is the common ratio every time you will see? Next time it will be 1 by 8 square, 1 by 64. Every time it is becoming 4 times. Correct? Look at this. This is 1, then 4, then 16. Next will be 64. Every time difference of 4. Correct? Difference of 4 times. Like not difference. Multiply by the 4 times. Sorry. Correct? So if you calculate in this case, how will you calculate? Numerator is 1, a value is 1. Here 1 minus, what is the difference? 1 by 4. Okay. It will be 1 by 4. Fine. In this case, a is 1. Yes, Varinder, 1 by 4.
दोबारा बता सकते हो?
Huh. So what I just said, K formula is this. G m1 m2 by r square. Mass is same, so G m square. First time R value is 1, second time 2, third time 4, and every time it will become double. Got it? So if you take first time, 1 square will be 1, 2 square will be 4, and 4 square will be 16. Next 8 square will be 64. So what is happening? In every time we are multiplying with 4. Correct? We are multiplying with 4. Correct? In denominator. So if you see above value will be equal to A. So A value is 1. Second, R value, every time there is a difference of 1 by 4. So R value is 1 by 4. Now you can calculate. If you calculate, your value will be equal to 4 by 3 gm square. And it will be used at many places. So tell me, any doubt?
No, sir.
Yeah. And remember, all these things we are doing for very first time. So you are doing easy question PYQ. Once we done with the syllabus, we'll do revision of every chapter, every single day one chapter, and then we will solve only question, no theory. Revision of theory just in 5-10 minutes, and after that only questions. Like one topic, one question, one topic, one question. Because in physics you still need more questions. But when it comes to the gravitation force, you know, if uh, one force act on the another, then direction will be different. Example, if you take this x-axis and y-axis. Example, if you take, you have a mass m1 and you have another mass m2. Right? This m1 mass is this m2 mass is this. Example, this is r2 vector, this is r1 vector. Okay. So what will happen? What is the distance between both of them? That's what matter for us. Distance between the two body. This is what matter for us, and we take this as r vector. Distance between the two body. If you calculate here force acting on body 1 and body 2 are opposite to each other. Example, body 1 attract 2 toward it and 2 attract 1 toward it. So that's why you will say force on 1 by 2 will be equal to minus force acting on 2 by 1. But magnitude will be same. Their magnitude will be same. Exactly same amount of force is acting in both the situation. But direction is opposite. Understood? If you calculate in the unit vector form, how will you calculate? G m1 m2 by r cube r unit vector. Is this correct? Is this correct?
Yes.
No, it is not. It should be square, not cube. And remember one thing, all of you, keep giving answer even if it is wrong. Doesn't matter. You are trying. You are trying in a way ki you are answering. You will make mistake next time. You'll feel ki okay, I have to make myself better. But keep giving answer even if it is wrong. Okay.
Sir, if it is R vector, then it will be R cube.
Yes. If it is r vector, then it will be r cube. Example, if I take same thing but in the vector form, so g m1 m2 by r cube, and here it is r vector. Why? Because unit vector is equal to vector divided by magnitude. Correct? This is unit vector. What is the role of the unit vector? Just to give you direction where it is moving. Unit vector is always the direction. And what does it signify, this part? It signifies that Newton's third law. Newton's third law. Every action has equal and opposite reaction. Makes sense? Yes or no?
Yes, sir.
Based on this, let's solve one question. Two particles of mass 2 kg and 3 kg are at point 1, 2 and 4, 6 respectively. Okay. Gravitation force on 3 kg particle due to 2 kg particle is. Now you don't have along a line. This is between the line. Solid. And I will check all of your question also in physics when you are sending. And today you will send me. I will check. I will tell during the class you didn't solve it, and then we'll end the session. Okay. So first you will send me notes. I'll check everybody's notes. I'll check did you solve all the numerical. It's okay if it was wrong, no problem. I'll explain. But you have to solve your own. First mass was 2 kg. X-axis, let's take this is 1.
1.6 in 10 to power minus 11 Newton.
Okay, 1, 2. What? How much?
1.6 into 10 to power minus 11 Newton.
Okay. 1, 2, 3, 4, 5, 6. And here, how much? 1, 2, 3, 4, 5. First body 2 kg mass is placed at 1 at x-axis and 2 at y-axis. Here. This is 2 kg mass. Okay. Second, 3 kg is placed at 4 kg at x-axis and 6 at y-axis. Here. This is 3 kg, 4,6. Right. So it means this will be attracted in this direction. This will be attracted in this direction. Force amount will be same. Correct. But remember, you always how to calculate the force. Force is equal to minus gravitation force and unit vector minus, because unit vector direction is always opposite. Correct. Unit vector direction is always opposite. Example, if you are thinking ki gravitation force acting on 3 kg, any doubt? So we have to calculate how much force is acting on 3 kg. How much force? This force is acting negative direction, in downward direction. Correct. So that's why when you calculate here, what is the unit vector? Then you know unit vector is equal to r vector and magnitude. Correct. What is the r vector? Final minus initial. Final value is 4 I cap plus 6 j cap. Initial 1,2 I cap plus 2 j cap. Divide by what will be the unit vector between them? 5. Tell me any doubt? And if you ask how, sir, because if you take 4I minus I, it will be 3I. And if you take 6j minus 2j, it will be 4j. If you take in this form 3 square plus 4 square, it will be equal to 5. Yes or no? That's why it is 5. What will be the unit vector value? 3 I cap plus 4 j cap divided by 5. Correct? Now you can put value. Force is equal to minus G, value 6.67 into 10 raised to power minus 11. One mass is 2 kg, another mass is this. Divide by what will be the value r square? 5 square 25, and r unit vector 3 I cap plus 4 j cap, divide by 5. Any doubt? Done. This is the answer. So understand, you have to take this unit vector. That's all. If I have to summarize key, what is special in this topic? Special is that you have to take unit vector. This is the most crucial thing. Otherwise, force you can calculate G m1 m2 by r square. Any doubt, guys?
No,
sir.
Anybody have doubt in this? Do you have a little bit background noise, or too much, or not at all?
There's nothing,
Not
sir.
at all.
Am I audible in better way?
Yes, sir.
yes, sir.
Yeah. So, anybody have doubt, Sarah?
No, sir.
Jordan,
No, sir.
Sandana,
No, sir.
Varinder Kaur?
No, sir.
We will not ask for the next. Gravitation field. This part is done. Now we can move to the gravitation field. Like you have electric field, same here we have gravitation field. That's why you can compare everything with electrostatic. Like how there you have electric field, we have gravitational field here. Correct? So it is the region around the mass where you can feel gravitation force. Correct? It is the region in which gravitation force is felt by the another mass. Correct? And when we see the gravitation force, gravitation field, as you go away from the body, it will decrease, because in electric field it was like A Q by R square. So what was happening there? Uh, Inversely proportional to the distance. More distance, less electric field. Same here. In case of gravitation field, I will use I. In case of this gravitation field, it is inversely depend upon the distance. Correct? So we can say I will decrease if R is increased. Understood? And definitely depend upon the mass. So directly depend upon the mass. Okay? Any doubt? Directly depend upon the mass, inversely depend upon the R square. But what is the formula? When it comes to the gravitation field, the simplest formula is how much force is exerted on the unit mass. Force on the unit mass. So what was the force value? Um, G, M1, M2, let's take capital M, by R square. This was force divided by M. So what will be the value? Gm by R square. Any doubt? Like I will keep on comparing with the electric field of 12th class. In case of electric field, you have how much force is experienced by the charge, and it was equal to K Q by R square. almost same thing. Anvika is not here. Just give me 1 minute. So whatever we'll do here, we'll compare with the electric force. Even same thing we'll do here also. In case of this force, if you compare with the Coulomb's law, in case of Coulomb's law, force in the charge, I will write the Q will be equal to K Q1 Q2 by R square. Correct. But what was the special in this case? If you take special thing in this situation, it is 1 by 4 pi epsilon and epsilon naught both. Okay. So what happened in this situation? In electrostatic force, you will see that you have epsilon and it depends upon the medium. Correct. But in gravitation, it does not depend upon the medium. This is the difference. Correct. Both depend upon the point mass applicable for electrostatic also. Correct. Obey third law, electrostatic also. Electrostatic force one of stronger compared to the gravitational force. Correct. Electrostatic central force, conservative force. Everything is same. Close path zero. I will tell you difference. What are the difference between this? Any doubt, guys?
No, sir.
No.
Yeah. So, as you know, electric field is a vector quantity. Correct? Same way, this gravitation field is also vector quantity. Correct? This is also vector quantity. What will be the direction of the gravitational force? Here, direction of electric field direction is same as electrostatic force. Here, same. Direction of the gravitational field is same as same as gravitational force. Any doubt, guys? Here, you will say uh, unit of the electric field will be Newton per coulomb. Here, unit will be Newton per kg. Correct? Right? If that's why every time I will leave space for the electric field. Here we'll talk about only electrostatic. Okay. And here we'll talk about the gravitation. And here we'll talk about the which criteria we are talking about. Now it will be easy, guys, right? I will show. Right? Are what is happening? Now this is correct. So why I am doing this? Comparison will become easy. Whatever we did, we can compare. Example, if you see force, in case of gravitation force, it will be equal to G m1 m2 by r square. Here electrostatic force, it will be equal to K q1 q2 by r square. Then medium independent, this dependent, correct? Quantity, scalar or vector. So electric field and gravitation field both are vector, correct? Here unit of this will be Newton per kg. This will be Newton per coulomb. Anything else we missed from the previous slide? Direction same. Next, move to the what is the gravitation field intensity due to the point mass. Then I will write field intensity here. So next, field intensity. If you take gravitation field intensity, it will be equal to Gm by r square and then unit vector. Same here, electric field will be Gm by kq by r square and the unit vector. Understood? Because it depends upon the positive and negative charge. If it is positive charge, direction will be exactly same. Okay. Why there is a sign? Example, in this case, you have negative sign. Here you don't have negative sign. Why? Because negative sign indicate force is attractive in nature. Any doubt, guys?
No,
No.
sir.
If you take multiple force electric field intensity together, then you will see कि it will be simple vector addition. It will be simple vector addition if you take because of the multiple particle. So next is multiple particle. If you have what happen? If you take multiple particle, simple rule is superposition principle. Barinder, what is superposition principle? Total electric gravitation field intensity will be gravitation field intensity of all. 1, 2. Same here, electric field total will be electric field because of the first, second, and many more. This is superposition principle, simple addition. Correct? Any other comparison. Yeah, there are many more things. If you take because of the different sphere, what will happen? Because of the sphere. If you have a sphere, how to calculate the gravitation field intensity and electric field intensity? If it is present outside, case 1, if your R value is greater than the radius of the body, then you know electric field will be equal to Gm by R square. Easy to do. Here, electric field will be equal to Kq by R square. Correct? If you take second case, both radius are same. I will be equal to Gm by R square. Here E will be equal to Kq by R square. Correct? If you say take inside third case when R is greater than this is the crucial thing. Right? If you take inside, what will happen? In this case, if you calculate what is the value, then you can calculate inside electric field, sorry, gravitation field intensity will be equal to Gmr by R. It means it is directly proportional to the R value. Correct? If you calculate electric field, it depends which sphere. If you are taking solid sphere, sphere means we are talking about solid sphere. Same thing. Electric field, if you calculate K, Q, R by R. Okay. So if you draw situation, all the three situations together, how will you draw? Example, if this is the sphere, solid sphere, radius is R. First situation, if you are calculating your gravitation field intensity at this point, then it was the case 1. This. Second, if it is on the surface, then second case R is equal to this. Third, if it is inside, like here, if you want to calculate here, what will be the value? Then value you know directly depend upon the R value. But in negative sign. Why? Attractive force. Here also same thing. Same stuff directly depend, but inversely depend. So if you draw a graph of both, I will again. Okay. So if you draw the graph of both, in case of electric field, it will be like this is your electric field intensity. This is the distance. And here maybe example take at this point where R is equal to smaller. You know outside it inversely depend upon the R square. Inside directly depend upon this. So it will be here value will be maximum and after that it inversely depend upon the R square. Okay. What will be the value here? Minus Gm by R square. After that, you know electric field intensity inversely proportional to R square. Inside, electric field intensity directly depend upon R. If you calculate electric field for this solid sphere, it is positive. That's why first it will increase and then it will decrease. Okay, here R is equal to R. Why? Because electric field is positive in this case. If you take positive charge, it will be K, Q, by r square. Outside, again, E inversely depend upon the r square. Inside, E directly depend upon r. But it is positive. In case of gravitation, it is negative. Any doubt? Any doubt, guys?
No,
No,
sir.
sir.
But if you take hollow sphere, what will be the difference? All situation will be same except one. In case of hollow sphere, you will consider the inside because remaining other two will be same. What happen if capital R is greater than the small r? Inside, gravitation field and electric field is zero. Inside, gravitation field and electric field both are zero. Okay, so if you draw a graph for this is R, this is gravitation field, maximum value minus Gm by R square. Example, this is the maximum value. After that, it inversely depend upon. Next graph will be exactly same, but it will be zero. See, this is zero. This is zero.
So is it because there's no mass in the center of this
Yes,
sphere?
exactly. Because inside there is no mass. Same. Inside the hollow sphere, there is no charge.
Yes, sir.
Only thing is, in case of electric field, you take the positive value. Okay. Here R is equal to R, and here example you take E is equal to KQ by R square at this point, and then it will decrease. Same way, E inversely proportional to R square. Correct? Any doubt?
No, sir.
Anybody have doubt in this comparison?
No, sir.
No, sir.
प्रत्येक के अनुसार
No, sir.
सारा
No, sir.
so this is enough for the comparison. Whenever there will be comparison, I will definitely do because I want to revise both chapters together. Many things will be done here. Correct? Same way, like whenever I'll do magnetic field, again I'll compare with the electric field. Okay. Whenever I'll do magnetic field, I will compare with the magnetic field. Do question. Example. We are doing third question, I guess. You have two mass. Like that. This is 2m. This is m. And distance between these two is 2r. At the center you have O, this is R, this is R. Okay. What is the net field intensity at the midpoint O? What is the net? I will write net field intensity at midpoint O. Calculate. Done. You know that electric field intensity is equal to Gm by R square and minus R unit vector because attractive in nature. Why minus in case of gravitational force? Attractive in nature. Now you calculate for both. If you take I1, it is attractive, then answer will be Gm by R square minus I unit vector. Why minus I? Minus I axis. Correct? If you take origin, O take origin. If you calculate I2, then Gm by R square 2m because mass is 2m. G 2m and what will be the I value? Plus I. Why? This time it is in the positive. I2 is positive, I1 is negative. Okay. If you calculate total net gravitation field, it is the addition of all 1 plus 2, but remember vector form. Correct? This is equal to minus Gm by R square I unit vector and plus this is G2m by R square I unit vector. Correct? So plus 2m minus m. What will be the value? Yes or no, guys? Any doubt?
No, sir.
Now we will calculate for the neutral point and we'll calculate both electric field and magnetic field. Okay. So if you do neutral point where electric field or gravitation field is zero. Correct? Where electric field or gravitation field is zero. Correct? In this case, gravitation field will be zero. Here, electric field net will be zero. Example, if you take two mass, here this mass is m1, this mass is m2, distance between them is r, and you take any point from this point, this value is r1 and this value is r2. Same here. You take two charge q1, q2, total distance r. If you take any point, this where electric field is zero, it is r1, this is r2. Correct? Because uh, of mass 1 and mass 2, net electric field is zero, so they will cancel out each other. So both value are same. Can we say here Gm1 by R1 square will be equal to Gm2 by R2 square. Here K Q1 by R1 square will be K Q2 by R2 square. Any doubt? Correct. G cancel. Can we say R1 square divided by R2 square is equal to M1 by M2? Correct. Or if you remove this square part, then you can have same here. K will be cancelled. R1 by R2 square will be equal to Q1 by Q2 and then under root. Correct? Any doubt? But most of time NEET question will be very easy and you can take under root part. Example, one charge will be Q, another charge will be 4Q. So taking under root will be easy. Like it will be either 4, 9, 16, 25, something like that. It will be easy to do. Correct? If you say in this situation, R value is equal to R1 plus R2. Same here. R value is equal to R1 plus R2. So if you calculate any value R2 or R1, it's your choice. It will be equal to R minus R1. Yes or no? Correct. So what will be R2 value? R minus R1 under root M1 by M2. Here R1 by R minus R1 under root Q1 by Q2. Correct. You have to calculate R1 value. So this will be R1 divided by R minus 1. Correct. R1 by R minus 1 will be Q1 by Q2. Next, you can take to other side. R1 by R will be equal to under root M1 M2 plus 1. Same here. R1 by R under root Q1 by under root Q2 plus 1. Yes or no? Correct.
Yes.
So if you so if you take this, uh, it will be LCM. If you take LCM under root M1, no, M2 is enough, no? No need to take this. M2, it will be under root M1 plus under root M2. What I have to multiply by R. Same here, under root Q1 plus under root Q2 by under root Q2 into R. Right? So this is how you can calculate. But trust me, I have never seen difficult question in this case. How they will give, I'll tell you in both the situation. There are two mass M and 4M, and distance between them is R, where we should keep the test charge so it is 0. Example, if you take this R1, this take R2. So it will be Gm by R1. correct? And it will be G4m by R2 square. Gm will be cancelled out. R1 divided by R2 will be equal to 1 by 4 under root 1 by 2. Then you can calculate that. Same here. Example, you have Q and 16Q. So KQ by R1 square will be equal to K16Q by R2 square. Correct? K cancel, Q cancel. R1 by R2 square will be equal to 1 by 4. This will be so easy. They always give under root form, so it's easy to do. Otherwise, it will take a lot of time. Got it? And based on that, you can take Q. What is the total value asked? Example, you can write here R2 value is equal to R minus R1. R minus R1. Why? Example, if it is give the total distance between them is, let's take uh, 2 meter. 2 meter distance here, 2 meter distance here. So what will be this value? Correct? Cross multiply. 2R1 is equal to 2 minus R1. Same. 4R1 is equal to 2 minus R1. What will be the value? Go to another side. 3R1 is equal to 2. R1 will be 2 by 3. Here, go to another side. 5R1 is equal to 2. R1 is equal to 2 by 5. Yes or no, guys? It will be given very easy, only in this form, not the under root and also. But you have to understand, you have to take under root form. Question will be given in the under root form only. Any doubt?
No, sir.
Anybody have doubt in this? Don't hesitate, ask question. How many are there?
No doubt, sir.
No doubt. Pratigya, Sarah,
No, sir.
Sarah, now it has become easy for you because we are comparing with the electrostatic.
No doubt.
Yes, sir.
Okay. Sandana, how you are connected through the two account?
No, sir, I have some network issue. That's why it's apparent.
Okay, Jordan is also not there. Is he trying to join? No. Then we'll continue because only one topic is left, and even from this we should solve some question. Okay, do question. Question number 4. Find net gravitational force on the particle of mass m inside a tunnel present in a solid sphere. What does it mean? For example, you have a solid sphere. Okay, and you can fill it. How to fill this solid sphere? Now we can fill from this because otherwise it will take a lot of time. Okay.
Excuse me, sir.
Yes, Sarah.
Sir, I have my practical test even today for chemistry mock test. Like in an
And
hour I have. So is it okay if I leave now?
in an hour you have.
Yes, sir. I had to revise something.
Okay, just do this question, then we'll end the session.
Okay, sir.
You don't anybody with anything. This is the last question. So why I made this? It is a solid sphere. In this solid sphere, what happened? You have a hole, like this hole you have. Now, mass is present between this. Okay, it will take a lot of time. I will make it like only this. Okay, so this is solid sphere, but within the solid sphere, the, there is a like mass of this solid sphere is m and radius is r. Okay, this is present at P point, and from the center, P point distance is r by 2. This is r by 2. Here you have tunnel and calculate net gravitation force in this situation. So you can do this with the help of the gravitation field. What is the gravitation field inside the solid? G m small r divided by r cube. Correct. Here, small r value is equal to r by 2. Correct. Small r value is equal to r by 2. How to calculate force? Force will be mass into this, like how we do force is equal to charge into electric field. Here, mass into gravitational field intensity. So this will be G capital M small m by r square by 2. Done. Any doubt, guys?
No, sir.
Anybody have doubt in this?
No, sir.
Okay, then. So this was all about this. In next two classes, we'll easily finish this whole chapter of gravitation with comparison of electric field. Okay. See you guys then.
Okay, sir.
And you will have class at 2 o'clock. Okay. And send me notes. Sarah, you can leave. Send me notes and other people.